Anyway, so today I'm going to talk about successful ecological restoration, providing diverse benefits to public, local government, and industry. And again, my co-author is Richard Allward. He couldn't attend today. He's an environmental consultant primarily, and with the recent rain, he needs to be out in the field and doing his consulting work. Okay, so reclamation, restoration in general. I'm going to go through some important concepts to understand the rest of my talk. I'll talk about some of the challenges of restoration in the oil and gas industry, some of the research results from my work and others as well, some of the solutions to some of those challenges, and the benefits that brings to that diverse group of people. So some of the concepts, first I'll talk about ecosystem structure and function. And this gets a little wonky, but follow me and then I think it'll help you with the rest of the talk. Okay, so ecosystem structure and function, what we often think about as reclamation is putting the right plants back onto the disturbed surface. But what we really want out of reclamation is for those areas to start functioning better. So while in the past, let me see where there we go. While in the past, we've mostly, when we've had, this is a good functioning ecosystem with good species structure and good function. The services that these sorts of areas give to us. When we degrade those, we usually lose species out of that system. You can think about an oil and gas disturbance. We go in there, take all the vegetation out, and start from scratch. But it's also losing ecosystem function at the same time. So we depend on our natural areas for clean water. We depend on our natural areas for maybe plant productivity so that grazing can take place out there. So we lose those as well. So here's our degraded system. When we do reclamation of these areas, we often only think about, like I said, putting the correct plants back onto that system. But what we really want is actually to regain those functions. We want to have clean water, lack of erosion, lack of sediment yield. We want to have good production by the plants, and we want to have good wildlife habitat and that sort of stuff. So the first thing to think about is that we need to think about function even more than ecosystem structure. And how does this come about? The need for reclamation and restoration from exploitation. And one of the things that exploitation does in all of our different types of disturbances, like agriculture, is to simplify these ecosystems in both their structure and their function. So their structure, again, in agriculture, you've got a single species in this area, and it's not going to function in all the same ways as a natural ecosystem. That homogenization or simplification of these landscapes can be seen with oil and gas disturbance. This is our most recent publication that came out in January of 2015. What we did there was we looked at 10 different areas and measured soil organic matter in the soils. And we used 2 reference sites and 8 abandoned and sometimes reclaimed. The newer ones had been reclaimed oil and gas well pads. When you look at a map of what the soil organic matter looks like, this is a map of the plot from a reference system. And the green areas are low in organic matter, and the blue and green areas are low. The red and yellow areas are high levels of organic matter. And what is true of this site is that it's dominated by big sagebrush, and I could probably predict with pretty good confidence that you'd find a big sagebrush right there, and another one right there, and another one right there, and over there, because they have that ability to put organic matter right underneath of those shrubs. And of course you know that topsoil is gathered from oil and gas well pads and stockpiled, and then it's spread back around, and some reclamation is done. This is a similar sort of plot from a well pad that was finished in 1971. And so you can see the organic matter there. First off, there's not very much organic matter, and you just don't have those pools of organic matter like you do in this particular case. This well pad actually had quite a bit of shrubs on it, but they were mostly rabbit brush instead of big sagebrush. So that's a good indication that we need to do reclamation well, because we need to get the functions back. This type of a system is probably more resistant to further damage. It has a good amount of different species present. It has big sagebrush, so that's important for wildlife habitat. And it would probably resist drought and other disturbances a little bit better because of that heterogeneity. This system is much more likely to be impacted by drought and other disturbances in the future, just because of the homogeneous nature of that well pad. And getting back to, again, why do we want to do reclamation and be successful at it? It really is to bring back these ecosystem services. This is from a website on the economics of ecosystems and biodiversity, and these are the type of ecosystem services that we do get out of these natural systems. Food, clean water, wastewater treatment, erosion control, pollination for our plants, wildlife habitat, recreation. It turns out that reclamation or restoration ecology is a pretty young science. We've only been around for about 30 years or so. So we're still kind of developing these different thoughts. But we've made really good progress. And so again, this is thinking about what we want out of these systems, these ecosystem services. In this particular case, they're looking at a wetland area, clean water, natural areas for recreation, flood control and erosion control, food. These are the ways that the functions that we can look at to make sure that we have these ecosystem services. Things like primary production by the plants. That has to be good in order to get all these services out of here. Nutrient dynamics in the soils, like that soil organic matter that I was talking about before. We need to make sure those functions do very well so that we get these services out. And like I said, we're pretty young science, but here's the restoration toolbox, the ways that we can make sure that we get those functions back, so we get those ecosystem services back. Okay, so some of the challenges specifically in oil and gas reclamation and restoration. Well, of course, it's a catastrophic disturbance to the ecological system. You go in, you remove all the vegetation. The soils and subsoils are removed separately, and that's a really good thing to keep those soils, the topsoil and the subsoil, separate. But then they're generally stored on site in a pile for a few years, up to many years. They're homogenized when they go through that process. When the oil and gas disturbance, when you're ready to do reclamation, the soils are replaced, first the subsoil and then the topsoil, but sometimes the subsoil and topsoil mix together. And that's bringing a real nutrient poor subsoil into contact with a more nutrient-rich topsoil. It can also bring salts closer to the surface and cause some other problems with infiltration and things like that. Oftentimes we're revegetating with a really simplified mix, sometimes of natives, but sometimes with non-natives as well. Crested wheatgrass would be a good example of a non-native that, in the past anyway, has been used a lot in oil and gas reclamation. In the past also, mostly around here, there's been a lot of reclamation work with just grasses. And it turns out that, again, shrubs are a really important part of these ecosystems. It makes those areas function better, and it is important for wildlife habitat to get those areas back into that kind of shape. So that can be a problem. And then there's conflicting restoration objectives and requirements. So for instance, the requirement for stormwater and erosion control sometimes conflicts with the requirement for wildlife habitat restoration. So initially, the most important thing is to make sure that you don't have any more soil losses when you're doing reclamation. So the most important way to do that, or the most valuable way to do that, is to get the coverage by grasses. Well, to get plant cover. And the easiest way to do that is to establish grasses. But like I said, for wildlife habitat, you need sagebrush, you maybe need some rabbit brush, you need some grasses, you need some forbs, which are the flowering plants. You need that diverse mix. It turns out that shrubs and forbs are harder to get established. So when you want to prevent erosion, you want to get stuff established right away, and that's mostly grasses. And in addition then, when you do that, those grasses, they have a real fibrous root system right near the soil surface, and they compete with getting shrubs and forbs established afterwards. So you do a great job of meeting those stormwater and erosion requirements, and then it makes it harder to actually get back the function that you want out of this system in the long run. So that's somewhat of a conflicting problem in oil and gas revegetation. Also, I know that the COGCC requires, and BLM requires that reclamation take place in the first growing season within 6 months of the closing of the well. And that can be a problem. We're much more successful if we seed in the fall, where we know the seeds can go through a winter time, and they'll be ready in the soil, ready to go when the spring rains hit, when the spring melt happens and stuff like that. But if that's with that requirement, a lot of times spring planting also has to take place. So that's kind of a conflict in some of the requirements. Other challenges out here in the Piceance and most places in the state and in the western United States, of course, it's dispersed energy development. As you can see from this aerial photo here, 1 to 16 well pads per section, continually adding new wells and making further disturbance, and then also this linear disturbance of roads and pipelines. That leads to habitat fragmentation. If there's an organism that doesn't really like to be near roads, they might not cross it for migration, for nesting, for things like that. A lot of work has been done on birds and how they react. Also, repeated disturbance. Multiple wells on one well pad is a great thing because it does decrease the total amount of disturbance that's out there. But of course, when 5 or 6 wells are drilled and then you wait a couple of years and come back and redisturb that area, it gets harder and harder to restore that area every single time. When you remove the topsoil and replace it and then remove it and replace it, you can imagine that that topsoil gets a little thin. So that makes it a little bit more difficult. Of course, our arid and semi-arid climate and the unpredictable nature of it. I tell my students a lot of times that you really need to plan on doing reclamation maybe a couple times because you can't tell. If you just have a really dry year, or if it's just really dry in April and May when your seeds are germinating, you might have a failure there. Weeds, of course, they're the bane of all restoration projects. Again, with my students, they have to do some projects coming up with a restoration plan, and they have to have a weed management part of their project because they're going to come. Some of them are worse than others, but you do have to plan on that. And remoteness. So a lot of these well pads are more than 50 to 100 miles from a nearest town. That's harder to get into. It's also harder to go back and monitor and make sure that your restoration is going in the right direction. There are over 15,000 wells here in northwest Colorado. That brings across some challenges of its own. So of course, here we are, the Piceance right here. Here's Grand Junction and Rifle and Meeker and Rangeley. And many of those are within important wildlife habitat. Winter range for elk, mule deer, pronghorn, bighorn sheep, cutthroat trout, eagles. sage grouse, can I say it? I'll say it. It's sage grouse too, habitat in a lot of places as well. And of course there's other uses of these areas, especially on public land, multiple use public land. It's important to do this restoration well so that we can get back some of the hunting, fishing, grazing, photography, all sorts of different uses of these areas. Okay, a little bit about the research results. Like I said, so I won't go through too many of them, so I won't be quite that wonky. Like I said, though, restoration is a pretty young science, and we've come a long ways. We know some things that, in general, are very helpful for restoration. For instance, a lot of restoration projects in the past, and in oil and gas, reclamation, restoration, it's really important for those heavy equipment operators to do the best job that they can, and oftentimes that's to make the flattest surface that they can. We're learning a lot about putting microtopography into those areas. Another study that we did out at the Colorado National Monument, the transplant success of shrubs was greater when we put a piece of firewood right next to them. To the south side of them, it provided a little bit of shade. It provided a little less evaporation out of the soils, so they had a little bit more water that was available to them, and they survived a lot better. So just having heterogeneity in that system like that instead of having the flat surface. And so more and more operators on pipelines and on well pads are putting back the slash onto that surface of that well pad. Again, it just creates a little bit different microenvironment. Different species are going to do better in some places versus other places. So we do have loss of ecosystem services. This is a study that was done on the loss of plant production. And they looked at across the western United States and the loss of plant production. What they said was that the equivalent of, in rangelands, the forage loss would be equivalent to 5 million AUMs, 5 million animal unit months, across the whole western United States, not just in Colorado. I'm just showing you here in Colorado. And that's being shown up here in this graph. It's from 2000 to 2012. This is rangelands, and the percent of percent of biomass lost per year. This is in croplands. The equivalent would be 120 million bushels of wheat, which is 13% of the total wheat production in the United States. Or it would be the equivalent of 3 Yellowstone National Parks. Of course, it's dispersed all over the place, and so that's kind of a strange way to think about it, but that's one of the functions that we need from these areas. So when we think about reclamation, we want to make sure that we get primary production. We need to get those plants back and functioning. There are a number of studies that are looking at incomplete restoration after oil and gas disturbance. This series of slides right up here is showing the same roadway after it had just been reclaimed in 1986, 1992, 1995, and 1996. Even after that period of time, and in an area that's a grassland and fairly easy to reclaim because you can do drill seeding, you can still see the border of where that road actually was. So probably it's not functioning quite the same. And this is a series of pictures from our study up here in the Piceance. This was the well pad that was abandoned in 1961. So again, you can see that there are some shrubs on there, but there's big interspaces in between those shrubs. There aren't very many grasses. There's not very much of an understory. This was the one that was abandoned in 1982. It's surrounded by PJ, and we did get a couple of PJ in there, but again, mostly grasses and mostly the introduced crested wheatgrass in that area. This was the one abandoned in 2004. Of course, it hadn't, our study was done in 2008. And of course, it hadn't had very much time to recover. And this is a reference site with, again, a couple of pinyon and junipers, but mostly big sagebrush dominated. The loss of wildlife habitat from oil and gas disturbance is pretty well known. This study was done in Wyoming, and a lot of our wildlife studies have been done in Wyoming, in the Jonah field. And what this is they collared some mule deer in this area, and they looked at what was good habitat, and this was before any oil and gas disturbance. And you can see that they're using most of this area, not here down towards the south, but the inner part of this area. They had been recorded in all of those different habitats. This is just a couple of years later after the road and pipelines had been put in, and so you can see that this area is now fragmented. Here's some pretty good quality habitat, and here's some pretty good quality habitat, but not in the center. And this is a couple of years after that. You can see that area has spread, and so there was a thought that maybe mule deer would get used to the activity, but clearly they're still avoiding that road. Probably not because of it's disturbed now, but maybe because of noise, traffic, that sort of stuff. And even after the wells were pretty well functioning, and there wasn't very much traffic and noise, the mule deer weren't coming back. And of course, media coverage can be a challenge, and it can be a problem as far as, again, if you get negative media coverage, people are much less likely in the future to be ready for more oil and gas activity. Oops. This article right here was in the Sunday Denver Post just a couple of weeks ago that you might have seen, just taking a picture of this well pad. They're actually, probably it's not all that bad because it probably was just done, and there are some grasses coming up, and this is on the Front Range, so it would be mostly grass dominated. But it doesn't look very good, right? And they also looked at the wells in Colorado that had been abandoned and hadn't been reclaimed. And this is the state of Colorado with that. They included that on the online version of the paper. This is a headline from the Grand Junction Daily Sentinel from 1998. You can see well site reclamation failing. Only half of the Garfield wells are actually getting very good reclamation. Of course, again, oil and gas has come a long way from that as well. Garfield County gas rules not tough enough, and that was along with this 1998 paper or story right there. Okay, so that also brings up this idea. I've been using the terms reclamation and restoration, both of those. What should we be going for out there? Reclamation is usually what we think about. Reclamation, returning mining or disturbed lands to pre-mining conditions or to an approved post-mining beneficial use. That comes from SMACRA, the coal mining legislation that was passed in 1977 by the U.S. Congress. So we want to return it to being a usable landscape and that sort of stuff. But maybe we should be thinking about ecological restoration a little bit more too. The process of assisting the recovery of an ecosystem that has been degraded, damaged, or destroyed. And that gets back to what I was talking about with the ecosystem structure versus function. If we're thinking about reclamation, we're thinking about getting the right species there and only that. But again, what we really want out of these landscapes is function. So we need to think about what plants that we can't just have cover, but that we need to have big sagebrush so that we can have wildlife habitat. Or we do need to have cover, but it needs to be more similar to what the natural area is so that we don't have as much erosion and that kind of stuff. Okay, so what are some of the solutions to this? I think that we should focus on performance-based standards instead of best management practices. Best management practices are really prescriptive. They say, for instance, that you have to seed out there within 6 months of closing down that well. And again, like I said before, sometimes that's not right. It's better to seed in the fall. So if it takes 9 months to get there, it seems to me that it's a better thing to do than to have a reclamation failure because you had to seed in the spring. Okay, so performance-based standards as opposed to best management practices or prescriptive practices to identify the goals and the objectives to be achieved. So what kind of plant cover do you need there? What kind of species diversity do you need for that function of good hydrology, good infiltration by water and stuff like that to occur, rather than you need to have exactly, you need to go through exactly these steps and we sure hope it works. The performance-based standards gives a lot more, I think, the due that the reclamation specialists in the oil and gas industry deserve. And that is, they know how those systems function. They know that planting in the spring isn't as good as planting in the fall. And so it should be up to them instead of being prescriptive. There are some things that need to be prescriptive, I think, like that you stockpile the B horizon, the subsoil and the topsoil separately, because we know that really works and is really important. But there can be some leniency in there as far as the operators doing what they think will really work. But if you do that, then you have to have goals. You have to have them set out beforehand in a reclamation plan, and you have to monitor to show that you've reached those goals. So it's kind of either or. Either it's really prescriptive and you do these things, or you really have to set aside the time and make the effort to come up with the goals and then also go back and show that you've met those goals. That can be really important. And it's really important to monitor it as it goes along to make sure that you're in the moving in the right direction. So adaptive management is the ability to go out, see that, oh, I've got a weed problem, I need to take care of it, or I don't, if it's nothing really important. This is just a study that is showing the way that there were changes in canyonlands and arches in the vegetation there, and you can see that in this particular case, this is through time, and in this particular case, there's not much vegetation change through time, which is on the y-axis. So that's probably not much to be concerned with. This one has a lot of change through time. I think that site had been invaded by cheatgrass, actually. This one, there's no change through time, and this one changes, and then it changes back. That's the kind of ecosystem that we want. Again, that means that there was some sort of disturbance, maybe a drought, maybe a die-off of pinyons and junipers or something like that, and then the ecosystem recovered and was much more similar to what it started with. Okay? And this right here is just a little study of some well pads, also in Wyoming, I believe, and it was just how much vegetation cover, how much bare ground did you have in areas in a reference site versus non-monitored well pads versus in monitored well pads. And again, the act of monitoring isn't going to make these monitored well pads better, but you are going to be able to do adaptive management if you go out and look at that well pad. Okay, so some of the benefits. This is a graph from a study that looked at 89 different restoration projects. They lasted from anywhere from 5 to 300 years, all over the world, actually. And what they found when they compared restored to degraded areas, so a degraded area versus a restored area, is that the function of those ecosystems in those restored areas was much greater. So there was higher biodiversity, there were more supporting services, there were more regulating services as well. There were a few less provisioning services. Actually, that's not significant, but that's not to be worried about. So anyway, so if you restore these areas, they do function better overall. However, if you look at the restored area versus the degraded area, or I'm sorry, versus a reference area, you can see that actually the reference area is still functioning better. So while restoration is really important to get back some of those ecosystem functions, we should probably not, we should try to minimize the disturbance in the first place. This is a little bit more about the economics, the benefits of restoration. This was a study that was done all across the world as well. And what this is saying here, this graph right here, is talking about these different ecosystems. This first one is coral reefs, coastal systems, and so on and so forth, temperate forest, and then we get into woodlands that we find around here in the PJ, and grasslands that we find around here as well. And this is the cost of restoration. So you can see that it's most costly to do restoration in coral reefs and so on and so forth. Pretty low cost, actually, to do restoration in woodlands and grasslands. And this is the cost-benefit, or benefit-cost ratio. So you can see that these are not very costly, and the benefits, those better ecosystem services that we get out of those areas, are really important and really large. So doing restoration, again, especially in temperate systems, is really beneficial economically as well. This was a study that was done by Encana and some consultants, and presented at the Society for Ecological Restoration and the High Altitude Revegetation conference quite a few years ago, actually. And what they found was that, these two blue bars here is the cost of reclamation of well pads, and if they're successful. And this is kind of the range. So from a low to a high in different areas. But you can see similar sorts of patterns, very low cost in the low budget ones in these couple of sites. And this is the cost if reclamation fails. And the company has to go back in and do it again, because a lot of things didn't happen correctly in the first place. So again, reclamation success is important. It's important that we show it by monitoring, and it's important that you kind of get it right the first time. And that's probably not just going in and reseeding, but it might be going in and kind of redoing the site altogether. This was a study on the economic impacts of restoration in Idaho, and they looked at a few different years here, 2008 to 2013. They found that jobs were added in agriculture and forestry, mining, construction, professional, scientific and technical services, and administrative and waste services. So jobs were added because of that reclamation activity, and it was bringing in an average of over $10 million per year of economic activity into that area. So my conclusions: successful restoration does provide numerous benefits to the public. That gets better functioning ecosystems, gets those ecosystem services out of it, to industry who wants to have continued access to these areas, to state and local governments as far as economics go, perhaps, but minimizing disturbance of the area is the most cost-effective practice. And so, of course, having smaller well pads, having pipelines together, or roads, access roads that are together instead of each one separately, can be very, very useful. Great, thank you. I'm happy to take any questions.